Okay, before we move on to solving equations of exponential functions and logarithmic functions, there's a couple things I want to recap, or I guess that I didn't mention in the 7.4 video, the properties of logarithms, that I want to make sure we get covered before we do those example problems. So some of the properties we didn't mention were these two. When you have basically the inverse properties, these are things that kind of cancel out as you're working. So when you have a log base b of b to the x power, basically the log base b of b cancels out and we just are left with x. The key to this is, it says b both times here. That's to emphasize the point that those two numbers would be the same. As you can see in the example on the right, 10 and 10 to the 7th power, of course, so the log with 10 and 10 cancels out and you just left with 7. And the reason for that and why that is, if you go back to some of the other properties that we know, we mentioned that you can take this exponent and relocate it to the front. So basically this would be the same as the log x times the log base b of b. But we also mentioned that when these numbers are the same for a logarithm, that's equivalent to 1. So really this would just be x times 1. That's the reason why you'll just see x. Okay. And again, for the second property, inverse property, you see b to the log base b of x power. So logarithm is an exponent here. And since logarithms are exponents, this is kind of a redundancy. These are inverses of one another, exponents and logs. So they cancel out, but again, they cancel out if these values are the same, b and b. So you can see in this example, 10 log base 10 of 2 equals 2. That whole thing, the exponent log, will cancel out. That's a little bit weirder to see, but it's kind of noticeable. You can't really miss that. So that's the plus to that side. All right, but keep in mind that those values do need to be the same for it to cancel out, like you'll see in these just quick examples. For r, log base 8 of 8 to the 3x plus 1 power. Notice again we have that log base b of b. This cancels out. 8 and 8, those would be the same. That's all equal to 1. And really this just equals 3x plus 1. Right? Because that's all that we'd be left with. For s, you can see 2 log base of 2, 27. Remember this exponent and that log with the same bases cancel out. And we're just left with 27. And for t, we're just left with 0.9. The reason is the base, even though we don't see the base of this logarithm, that means the base is 10 because it's a common logarithm, which of course means 10 is the same as 10, thus making it cancel out. Okay, inverses of each other. What was I going to say? Not sure, but it'll come back to me. So for L, same thing, we're just going to have 11 because the log base 3 of 3 cancels out, they're inverses. Oh, I remember what I was going to say. Think back to, because this is the inverses of logarithms are exponents and the inverse of exponents are logarithms, but think back to when we did radicals or square roots and cube roots. You know, we took the square root of something if we wanted to undo it to the second power. You know, square roots and things that are squared are inverses of each other. So for example, if you took the square root, doesn't equal, I'm sorry, but inverses of one another. Okay, if you take the square root of x squared, you're essentially canceling out the square root with the squared, and you're just giving yourself x. They're inverses of each other. That's exactly what's going on here, but for logarithms. Exponents and logarithms are opposites of one another, so that's why these would cancel out. Okay, if the logarithm has an exponent, or if the logarithm is an exponent, those are inverses and they cancel out. So for n, we're just left with 10, and for e, we're just left with 3. All right, now the next biggest thing is the change of base formula. This formula can help you evaluate any logarithm you want on any calculator that you want. I think I mentioned in class, I don't remember if I mentioned in a previous video, but we can't type into like a regular scientific calculator or some of the older graphing calculators. We can't type in log, let's say base 7 of 16, right? We can't figure out what that equals on a regular calculator because a regular calculator doesn't let us input some base number here. Regular calculators just use the common logarithm. They only use logarithms with a base of 10. So you can only type in log of 16. But as we know, that's not the same thing as a log base 7 of 16 because common logarithms have a base of 10 and we can't change that in those older or scientific calculators. But with the change of base formula, you actually can evaluate this. So how I would write this, or how I would do this in an older calculator, or just a regular scientific calculator, is I'm going to change the base to anything I want. Notice here that log base b of x equals log base a of x divided by log base a of b. So we're still using the x and b, but we're changing the base to some new value. And the only reason we would really do this is to change the base to a common logarithm. I mean, you could change it theoretically to whatever base you wanted, but ideally the only reason you would do it is so that you can convert this into common logarithms. So this example here, log base 7 of 16, I could write this with the base of 10 as log 16 divided by log 7. Now notice I'm using common logarithms, right? I've changed the base to 10 so that I can plug this in my calculator because I can type in my calculator log 16 divided by log 7. And that's going to equal the same thing as it would have equaled if I had been able to type that in. So it's a little kind of a back road trick or backdoor that lets us evaluate any logarithm we want regardless of what the base is. So let me pull up my calculator and I'll kind of show you what that looks like. Okay, you can briefly see one that I did earlier in class, but let me do the example that we were looking at. So this calculator is a new calculator. So it actually has the functionality or the ability to be able to plug in any base we want. And to do that, we would hit the math button. And if you scroll all the way down to the bottom, but I just hit the arrow up key because it takes me to the bottom a little faster, you'll notice it gives us a log base function. And that allows us to plug in any base that we want conveniently, right? And we can solve any logarithm we want that way. But if we have a calculator that's older, it doesn't have that function on it, or you're just using a standard calculator, we can do, this is the same thing as doing, as we mentioned with the change of base formula, the log of 16, make sure we close our parenthesis, divided by log of 7. Okay, notice I'm not specifically mentioning the base because I'm changing the base to a common logarithm, a base of 10, but it still gives me the same value. So it's kind of a little trick. So any logarithm that you have, you can evaluate on your calculator if you use that change of base formula. Okay, basically you just take those two numbers in logarithms and you divide them. But it doesn't matter which one goes on top, which one goes on bottom. So keep that in mind. So for u, x, and w, log base 4 of 8, this would be the same as log of 8 over the log of 4. So we're converting them into common logarithms, and we can actually plug this into our calculator and evaluate. You know, we couldn't plug in this on a standard calculator, but we can plug this in a standard calculator. And I believe if you do, it comes out as 1.5, or if you get a fraction, it's 3/2. All right, same thing on this one. It's got a base of 9, but if we want to be able to do this on a standard calculator, we could just do log 27 divided by log 9, right? Using common logarithms here. And I believe that also comes out to 1.5, or again, 3/2. And this last one, it's the same old, same old. We can't type in that base, but what we can do is convert this into the log of 16 divided by the log of 8. And I do think that one comes out to 1.33. Okay, so it does matter, like I said, if you know which number goes on top, which one goes on bottom. Log of 8 divided by log of 16 would not be the same. So make sure you remember that. Kind of the way I think about it is I'm not thinking about the bigger number numerically, but the bigger number, like physically speaking, like that 16 is physically bigger than this 8. not just valued wise. I remember that this bigger number goes over the base number. So that's just, I don't know. Everybody remembers it a little differently, but make sure you don't get those mixed up. All right, to simplify these, this first one, again, with a standard calculator, we can't just plug this in, so we have to do some finagling to get this set up so I can actually use a standard calculator. And here's the trick. So one of the things we're going to talk about a lot in the upcoming videos when we're solving these equations is we don't really like to have exponents here. Those exponents are kind of an annoyance. That's why we learned the property where we can move this exponent to the front. So moving that exponent to the front, it's now 6 times the log base 2 of 32. Now that cleans it up a little bit, but I still have to evaluate this, and I can't type that in my calculator. However, with the change of base formula, I can. Log base 2 of 32 would be the same as log 32 divided by log 2, right? So I can type that in the calculator, and when I do, let me pull it up real quick. So when I type that in, log of 32, close the parenthesis. I always forget to do that sometimes, it messes up. Log of 2, and it equals 5. So that logarithm equals 5. So don't forget the 6 is still there. So really, it's just 6 times 5. So the answer is 30. Okay. So it did take a little bit of finagling, but all we really did was move the exponent to the front and then use the change of base formula to evaluate my logarithm. And I saw that this became a simple 6 times 5. And number 2, a quick example to recap what we did earlier. Notice the exponent logarithm, 2 and 2 cancels out. So this answer would just be 8x. And evaluate this last one. Again, this would just be the change of base formula. Same as the log base, or log of 8 over the log of 32. So remember, it's this number that goes over this one. All right, and I think when you solve that, I believe it comes out to 0.6 or 3/5. All right, I'm going to end this video here because the next one's going to talk about solving exponential equations, and I don't want this video to be too long, and that's a totally different section entirely. So I'll see you in that one, folks. Later.